about x equals 1.
And the axis is x equal 1?
Yep.
So here's the region to rotate, here's the axis of rotation, e to the negative x. Oh my goodness gracious. Well, before we start drawing all that difficulty there with e to the minus x, maybe I ought to draw the easy stuff. What does y equals 0 look like?
There's a straight line on that. How they work.
Yeah, it has another name. It's called the x-axis.
Yeah.
There's y equals 0. X equals 0 has an equally familiar name. It's called the y-axis. So they're using the coordinate axes. That was x equals 0 and y equals 0. X equal negative 1 is here. So I guess what we're just trying to do is see where e to the minus x crosses that. And what does e to the minus x look like? E to the x is increasing, isn't it? E to the minus x is decreasing. So it's going to be something like this, isn't it? And there's the thing we're looking at. Did they tell us which method to use? I think they want us to use shells again. So if I use shells, well, let me see. First of all, I meant rotating around x equal 1. Well, x equal 1 is out here. So if I rotate that around x equal 1, think, right, what I'm going to get is like, what's that, bat ears or something like that? Oh my. Oh goodness. Somebody want to help me set up this shell method? 2 pi, good way to start. Integrals a to b, radius times height, and dx or dy? How come you know it's dx?
Because it's rotating.
Axis is vertical, so the integral is horizontal. All right, radius and height of what?
That. Create a region.
Well, I've got to pick an x somewhere, anywhere I want in the region. But once I pick an x, I draw a line segment there and rotate that line segment. And it's the radius and height of that cylindrical shell that I'm trying to find. So the radius is this distance,
1 minus x, right?
which is always 1. And I want to add to it that distance. Yeah, notice here, x is a negative. So that distance is minus x, isn't it? Yeah. Like we said it. Yeah. You get it? X is, no matter where I draw my line segment in that region, the x always is a negative number, isn't it? So minus x is that distance. So the radius, by the way, the limits of integration, we're going from -1 to 0. 1 minus x is the radius. 1 plus a negative x. The height is just the y value from that curve. Now I can either distribute and do 2 integrals, or I can go ahead and try to do the integration by parts the way that's written. I think integration by parts will work okay if we just do it by letting u equal 1 minus x, and let dv equal e to the minus x dx. Now minus du is equal to dx, and v is minus e to the minus x. So 2 pi. U times v, let's put the minus in with that. That'll be an x minus 1, right? The minus sign changes the order of the subtraction. So u times v, x minus 1, e to the minus x, minus the integral of v du. And v du, the 2 minuses, well, there's 1 minus, and these 2 minuses cancel each other, so e to the minus x dx. And all this is from -1 to 0. Did I do that right? Stuff is making my eyes swim. So what do we have here? 2 pi x minus 1 over e to the x plus 1 over e to the x, all evaluated -1 to 0. Is that right? So I guess before I plug numbers in, notice the things will simplify nicely. If they have the same denominator, add the numerators, the ones cancel. So I have 2 pi x in the numerator over e to the x, and this is all evaluated -1 to 0. Is that okay? Plug in a 0, you get 0, minus. Plug in -1, and you get -2 pi e to the -1, so that is 2 pi e to the 2 pi e. Somebody write for me what you would have had there if you would have done it with the disk method.
X is negative and y.
Let's see, well, what I'm gonna do now, I already don't like the disk method. Because I'm gonna break it into 2 integrals to do the disk method, I'm gonna use 1 integral to find the volume above that red line. Below the red line, I don't really need calculus, do I? That's just a cylinder, and I can do, well, it's a constant cylindrical shell. So I guess really this still could possibly work. But I would only be going up above there. To do this, I'm just gonna use a geometry. So already I don't like that method. Already I think the shell method looked like a better method. Question? I think the disk method would have worked on that one though. Anyway, that was 63. Looks like it's already time for a break. Man, we haven't even gotten to the hard stuff yet. Let me see what the new junk is I'm gonna throw at you guys today. 7-3.